Hey guys, welcome to Stat 441 at Virginia Commonwealth University. This is part 2 of the lecture to understand the concept of testing a hypothesis. In the previous lecture, we discussed what are the steps that we can use to conduct a hypothesis test using the classical method. Today, we will learn about the p-value method or the significance level method. Either way, the first step is to write the null and the alternative hypothesis. So as you know now, there are two types of hypothesis. The first one is the null hypothesis, which is stated with the equal sign, and HA is the alternative hypothesis, which uses the less than, greater than, or not equal to sign, depending on what we are trying to test. Okay, so let's look at an example and write down the H0 and HA for this one. A metal lathe is checked periodically by quality control inspectors to determine whether it is producing machine bearings with a mean diameter of 0.5 inches. If the mean diameter of the bearings is larger or smaller than 0.5 inch, then the process is out of control and needs to be adjusted. So we want to write a null and alternative hypothesis for this. So here, the value of mu0 is 0.5 inches. And it is out of control if it's either larger or smaller than 0.5 inches. So it's a two-way test or a two-sided test. The mu value is the true mean of the diameter of all bearings produced in the lathe. So basically that's the population mean. And because it's two-sided test, the sign we use in HA will be the not equal to sign. So H0 will be mu equals 0.5 and HA will be mu is not equal 0.5. So here's the process in control, and it's out of control if it's not equal to 0.5. So the method that we will discuss now is called the observed significance level. So here is what how we use this method. So basically, the result of the statistical test reports to what extent the test statistic disagrees with the null hypothesis. So once we have figured that out, that how far is the test statistic in terms of probability away from the value in our null hypothesis, and then we decide whether to reject the null hypothesis or not to reject the null hypothesis. So this measure is called the observed significance level, or the p-value of the test. And this p-value is basically a probability, assuming the null hypothesis is true, of observing a value of the test statistic at least as contradictory to the null hypothesis. And then basically it will support the alternative hypothesis. So this p-value is calculated using the information from the sample data. And the steps for conducting the test using p-value will be these three. So the first step will be we have to decide our maximum value of alpha that we are willing to tolerate. Remember, alpha is the probability of making a type 1 error. So usually it's a small number that's chosen, either 0.05 or 0.01. 0.1 is also chosen. So we will choose the value of alpha. Then, based on what we have observed in the data, we will calculate the p-value of the test. Now, p-value will depend on whether the test is less than, greater than, or not equal to. And the next few slides show you how to calculate the p-value. And once you have the p-value, this is how we will decide. We will reject the null hypothesis if alpha is greater than the p-value, or the p-value is less than alpha. So we calculate the p-value here, compare it with the alpha that we have chosen in step 1, and if the p-value is less than alpha, we will reject the null hypothesis. So in this method, we do not have a need to define the rejection region separately. We just calculate the test statistic, then we calculate the p-value, and then based on that, we will make a decision. So it's a much easier method to use, and because again, we don't have to decide the rejection region for various types of tests, and the way we make the decision is also the same, no matter whether it's one-sided or a two-sided test. So here is how we will calculate the p-value. So let's say we have AHA with the greater than sign. So it's an upper one-sided test, and the test statistic, let's say, is a z. Okay, then the p-value is calculated as probability of z greater than z observed. That's your test statistic that you're calculating from the sample data. Okay, so it's a simple probability. If you see here, the sign is the same as the sign as HA. So we calculate this probability and compare it with the value of alpha, and then based on that make a decision. If it's a less than test, so here less than sign, p-value will be probability of z less than z observed. So this is our test statistic value using the sample, and we have learned how to use the normal distribution table. So we do exactly that to find this probability. If it's a two-sided test, we know that we have our rejection region on both sides. So the way we calculate the p-value here is either you can do this probability of z less than negative of the z observed plus probability of z greater than absolute of the z observed, or just simply this 2 times probability of z greater than absolute value of the z observed. So basically double this, and that will give us the p-value. Okay, so let's use this for an example, use this new information. The Department of Highway Improvements, responsible for repairing a 25-mile stretch of interstate highway, wants to design a surface that will be structurally efficient. One important consideration is the volume of heavy freight traffic on the interstate. Weigh stations report that the average number of heavy-duty trailers traveling on a 25-mile segment of the interstate is 72 per hour. However, the section of highway to be repaired is located in an urban area, and the department engineers believe that the volume of heavy freight traffic for this particular section is greater than the average reported for the entire interstate. So we have this specific area we want to test. So to validate this theory, the department monitors the highway for 51-hour periods randomly selected throughout the month. Suppose the sample mean and sample standard deviation of the heavy freight traffic for the 50 sampled hours are. So this is your sample data. Y bar is 74.1, S is 13.3. Does the data support the department's theory? We want to use alpha of 0.10. Okay, so for this example, what are we trying to test? We are trying to test that the average traffic is heavier than for the rest of the highway. So we are trying to test H0 mu is equal 72 versus HA mu is greater than 72. So we are trying to prove this. So the sample mean that we have picked, or the sample that we have picked from the population for a large sample size, it will be approximately normal using the central limit theorem. Okay, now the test statistic will be z is equal to y bar minus mu 0 divided by the sigma of y bar. So that's the z distribution. So y bar minus 72 divided by s over square root of n, since we don't know the value of sigma. Again, these test statistic formulas, we will discuss them in detail for each individual parameter. But for mean, this is the test statistic. Now, if we were to use the rejection region approach, we know that alpha is it was 0.1. So since the alpha is 0.1, we can create the rejection region on the right hand side. Remember, it's a greater than test. So the rejection region will correspond to a z value greater than 1.28. So basically, if you find the z value corresponding to a probability of 0.10 on the right hand side or 0.90 on the left hand side. Once we have that, we can use that as the rejection region. But we will rather use the p-value method, because in that case, we don't have to specify this rejection region separately. So we go ahead and calculate the the test statistic using the sample information. So 74.1 is the mean for the sample minus 72, that's number from the hypothesis, divide by 13.3 over square root of 50. So 1.12 is the test statistic. Okay, now this is how it's working. So we have a rejection region here corresponding to 1.28. The sample data or the test statistic is showing that this z value is 1.12. So it doesn't fall in the rejection region. So we will not reject the null hypothesis. Okay, so here is how it will work. The average number of heavy freight trucks per hour in the sample exceeds the state's average by more than 2. But the z value, so it's 70, this was 72, which was the average value given. 74.1 is what the sample is showing, which is 2 more than the average, but in terms of z value, it's just 1.12 away from the center. It does not fall in the rejection region, and therefore this sample does not provide sufficient evidence at alpha of 0.10 to support the department's theory. Okay, now if we had chosen a different alpha here, we would have 8 different rejection regions. The good thing about the p-value method is that you calculate the p-value and then it will stay the same, and then depending on your alpha value, you would just make your decision. So here is the observed value of the z, which is 1.12. Then we have a sample of 50. For calculating the p-value, because it's a greater than test, we just need to find the probability of z greater than 1.12. Okay, and this is how we can calculate it. Probability of z greater than 1.12 from the table. If you recall, using the z distribution table, it will be 0.5 minus a, which we look up from the table. Okay, so if you think about this, the normal distribution, 1.12, and we need the probability on the right side of 1.12. So we look this piece up from the table and subtract from 0.5. This, so we have 1.1314 as our p-value. Now compare this p-value with alpha, which is 0.1. So our p-value is greater than alpha. Since the p-value is greater than alpha, we will fail to reject the null. Okay, so there is not enough evidence to prove that the mean traffic is higher. When would we reject the null hypothesis? We would reject the null hypothesis only in cases when the p-value would be less than alpha. Okay, now what is this alpha value? Recall, it's the type 1 error, the maximum type 1 error we are willing to choose. Here again, what we do is p-value exceeds of our alpha of 0.1. And another way of saying this is the department has insufficient evidence to reject the null hypothesis. Here's an example with a two-tailed test, how to find the p-value when it's a two-tailed test. So we'll use the same example, the one with the highway. So in this case, let's say we were trying to figure out if the mu is different than 72. So it could be in either direction, and again alpha is 0.10. So if the test is two-tailed, this is what is happening. It cannot take very small or very large values with respect to our mu0, which is 72. And the way we can calculate this p-value is by finding the probability of z greater than 1.12 plus probability of z less than negative 1.12. So if you can see, the rejection regions are on both sides. This is the observed value, 1.12. So 2 times 0.1314. Another way of solving this is finding the probability, 2 times probability of z greater than 1.12, which again is this value, just the double of that. So 0.2628 is the p-value, okay, for a two-sided test. Now, let's compare the p-value with alpha. When we compare this p-value with alpha of 0.1, again, the p-value is larger than our alpha. We will fail to reject the null hypothesis, or we have insufficient evidence to reject the null hypothesis. Let's compare this with the rejection region approach. So since it's 0.1 or 10% area or for alpha, so we will use 0.5 and 0.5 and on either side, which corresponds to 1.96 and negative 1.96 on the left-hand side. Our observed value of false here, if you look at the two sides, 1.12 and negative 1.12, which is not in the rejection region. So these are the two methods that we can use. For the rest of the questions, we will use the p-value approach. So basically, there are 4 steps in conducting hypothesis tests. First, we will state the null and the alternative hypothesis. Then we calculate the value of the test statistic, find the p-value, and then compare the p-value with alpha to make our decision as to reject the null or fail to reject the null hypothesis. So this is in general how to conduct a test of hypothesis. Now in the next lectures, we will take one parameter at a time, discuss what the test statistic is, and conduct the test using this format. All right, thanks for watching.